just a couple of results I want to look at with regards to polynomials. So the first idea is this. If a polynomial has k distinct real zeros, then each one of those zeros, by the factor theorem, can be factorised as x minus a whatever. And therefore, there must be a factor which is each of those linear factors multiplied together. So x minus a1, x minus a2, x minus 3, a3, and so on, up to x minus ak, must be a factor of the polynomial. In fact, any combination you could pick out to be a factor. So, all right, this question, show that 1 and negative 2 are 0, so we can use our factor theorem for that. We know polynomial 1, yes, that turns out to be 0. Polynomial negative 2, yes, it also turns out to be 0. So we know 1 and negative 2 are zeros, so therefore x minus 1, x plus 2 is a factor. So let's complete the factorisation. But instead of writing down x minus 1, x plus 2, I'm going to write out the quadratic, because then it's easier to factorise by inspection. Then I can see all the individual terms. So I can use the same ideas we were using, leading term times leading term. So therefore it must start with x squared, constant times constant. So therefore the constant in the other one must be plus 5. All right, we've got a missing term in the middle. So let's have a look at the x's. At this stage, I have 5x. Nothing else produces an x, does it? So that looks like it's okay. I might double check on that just in case. Let's have a look at the cubes. There's only one cube. Yeah, no, 1x cubed. So it looks like, in fact, x squared plus 5 is the other factor. So total factorisation, x minus 1, x plus 2, x squared plus 5. All right, second result. If we know the polynomial is of degree n, and we also know there are n real zeros, then x minus a1, x minus a2, x minus a3, and so on is not just a factor, but then it must be the polynomial. Right? Because a polynomial of degree n cannot have more than n zeros. You don't have a maximum of n solutions to an order n. Maximum of 2 solutions to a quadratic. Maximum of 1 solution to a linear equation, and so on. And so that's what I was just saying. A polynomial of degree n cannot have more than n zeros. So we've got a polynomial. We're told there's a double zero at negative 7, a single zero at 2. What is a possible polynomial? And when they say a possible polynomial, what they're really meaning is a general expression that would cover every possible polynomial. So I know x minus 2 is a factor. I know x plus 7 squared would also be a factor. But it might not be a cubic. All it says is it's a polynomial. So it could be multiplied by some other polynomial. But that other polynomial can't have a 0 at 2 or negative 7. Because if it did, then our whole polynomial would no longer have a single 0 at 2 and a double 0 at negative 7. So the only thing I know about this other polynomial is it won't have a solution of 2 or negative 7. There's one other thing I can do. I could multiply it by any real number, because any multiple of that polynomial would have the same solutions. And it doesn't say that it's monic, so there's nothing to say the leading coefficient is necessarily just, x to the power of n. Okay, this time they're telling me it is a monic polynomial of degree 3. So I can start off the same again. Well, I know they're 2 factors, but that's it. Because what I've written down is of degree 3, so it can't be times another polynomial. And it's monic, so I know it's not times some real number. So in this case, there's only one possible polynomial that satisfies that. If it was a monic polynomial of degree 4, okay. So again, I know those 2 factors. At this stage, we're degree 3. So I can't just multiply it by any polynomial. I want to get it to degree 4. So I know it's going to be multiplied by some linear polynomial. So I've made it x minus a. I mean, you could still say times qx where qx is of order 1 or something like that. But a in this case can't be 2 or negative 7 for the same reasons as before. Monic, so I don't need to multiply it by some real number. A polynomial of degree 5. Okay, so at this stage it's order 3. To make it order 5, I would multiply it by something of order 2. Now, don't multiply it by x minus a, x minus b. Because you're assuming then that quadratic can be factorised. It might not be able to be factorised. So it's safer to multiply it by a quadratic, and this time I did write it as qx, where I know that's of polynomial degree 2, and it doesn't have solutions 2 or negative 7. In this case, I'll multiply it by k as well. I suppose when I'm multiplying it by qx, do I really need the k? Well, I'm actually saying you don't need the k in that case, because you're just saying qx is a polynomial. You didn't say qx was a monic polynomial. So actually it would cover that anyway. Whereas in part C there, although they have said they want the whole thing to be monic, if they didn't say the whole thing to be monic, I would have to put a k there, because x minus a. It doesn't really matter, I suppose, whether you put it there and you don't need it. I mean, it just covers all bases. Okay, a fourth thing. This is where I now contradict everything else we've said. If a polynomial is of degree n, and it has more than n real zeros, which of course contradicts what we just said, because we just said it can't have more than n real zeros, then the polynomial is a very special polynomial, and it's what we call the zero polynomial, sometimes called the null polynomial, N-U-L-L. In other words, polynomial x is 0 for every single value of x. It's a really unusual polynomial when you think about it, because what is its order? Yeah, I mean, well, we said the order. Another way of thinking about it, I suppose, is the number of solutions it could possibly have. How many solutions could this have? Yeah, I mean, px equals 0. It doesn't matter what number I sub in, I'm going to get 0. But then think about if I'd said px equals 2. How many solutions are there? There's none. Think of the line, y equals 2. If you were to draw it, has no x-intercepts. Just want to see if I'd catch anyone out on that, and people go, oh, well, that'll be infinite as well, because you could sub any value for x in and get the answer of 2. But that's not the point. It's the polynomial equaling 0. How many solutions does it have? In this case, we're saying 0 equals 0. How many solutions does it have? Well, 0 is always equal to 0. So it has an infinite number of solutions. So it's this really strange number 0, because is it actually there anyway? Because it's nothing, right? We just write that symbol so that people know we haven't just left anything off. I mean, it's just a symbol that represents nothing. So is it actually there anyway? Strange one. Yeah, as I say, it is that weird number. I mean, we can talk age about what is 0 divided by 0, 0 to the power of 0, and it's an interesting number if it actually is. There are some people who still think it's not a number.